In this video, we will be discussing section 9.6, which begins on page 593 of your textbook and is entitled Factor ax squared plus bx plus c. So, what we previously learned was factoring x squared when a was 1. Now, in this case, a is going to be a number, so it's going to just add an additional step into the factoring process. And there is a process, even though the way I'm going to have you learn it now is just more or less a little bit of critical thinking and then trial and error. So, when factoring a trinomial in the form ax squared plus bx plus c, consider the signs of b and c just as you did in the previous lesson. This approach works when a is positive. So if a is negative, we are going to want to factor out a -1 in the very first step. So let's go ahead and look at example 1. Factor when b is negative and when c is positive. So you still need to be thinking about not necessarily number-wise, but what multiplies to a positive that's going to add to a negative. So you're going to have, a little bit of critical thinking happening here. So I do need to think about the factors of 2 and the factors of 3. All right, because b is negative and c is positive, both factors of c must be negative. Alright, because a negative times a negative is a positive, and then a negative plus a negative is going to produce that negative. Alright, so make a table to organize your work. So, you also must consider the order of the factors of 3, because the x terms of the possible factorizations are different. Alright, what they mean by that is the only factors of that 2x squared minus 7x plus 3, there are a couple of different ways to factor 2. Either you have 2x times x, or you've got x times 2x. Alright, and then you've got that 3 in there, which is going to be a -3 in with the 2, or you've got that -3 that's going to be in with the 1x. And then that has to be multiplied by a -1. Alright, so making a table that is organized, alright, and goes in a consistent manner is only going to help you. So there are only a couple of factors of that a term, factors of a versus factors of c. You've got 1 and 2, and then you've got -1 and -3. Notice they keep the factors of a written consistently, and then they go ahead and change out which factor of c is going with which factor of a. Alright, and you can see how it's written in the next step. So then when they multiply out that, if I were to talk about that FOIL process, multiply the inner and the outer terms, inner and the outer terms, we want to go ahead and see which ones match up with what our b value actually is. And that's -7x. Alright, so the bottom arrangement, alright, is going to end up being our final answer here. So if I were to fully FOIL this out, I should get that 2x squared minus 7x plus 3. So this is my final answer. Alright, and the higher the numbers get for a and c, the more options that we are going to have. So here in example 2, factor when b is positive and c is negative. So what multiplies to give you a negative number? That's going to be a positive and a negative number. And then I need to think about the cases in which that positive number that I multiplied is going to be larger than the negative number, because I need to produce a positive number here for b. So I need to look at my factors of a and c. Okay, so heading towards my solution, b is positive and c is negative. The factors of c are going to have different signs. So when I look at my parentheses here, I am going to have a plus or a minus. So looking at the factors of a, I only have 1 and 3. And then the factors of b, it's a little bit different since the signs are going to be different. Alright, so keeping all of my a values here consistent, and then changing my sign. 1 times -5 is going to produce a -5. But -1 times 5 is also going to produce a -5. Alright, so I do need to keep in mind the order matters, and exactly which set of parentheses I'm placing them in matters. So, if I write out my 1 and my 3 here to get that 3n squared, I'm going to do so in every set of parentheses, and then I'm going to change out these constants in each of these binomials. And then, through the process of multiplying my inner and outer terms to see what the sum to produce that b term is going to be, through the process of elimination and trial and error, I get this arrangement. Alright, so I get that desired 14n by multiplying out my inner and outer terms through trial and error. Alright, so this is my final factored form. So go ahead and try out some guided practice, pause the video, and see if you get the matching solutions. So keep the signs in mind and keep the factors and the different combinations of A and C in mind when you guys move for the solution. Alright, so factoring when a is negative. To factor a trinomial in the form ax squared plus bx plus c, when a is negative, first factor out that -1. Alright, we love when a is positive. We like starting out on a positive foot, of course, and it just makes it easier. Alright, factor out a -1 from every single term of the trinomial, and then factor the remaining trinomial. So I'm really just going to, throw a -1 out in front and change all my signs, forget about it until the very last step, and then make sure to rewrite it in the end. Okay, so factor out -4x squared plus 12x plus 7. So if I factor out a -1 from the trinomial in the first step, my result is that 4x squared minus 12x minus 7. Alright, changing out my signs. And then I want to go ahead and factor the remaining trinomial. So I need to consider my signs here and the factors of A and C. Alright, because B and C are both negative, the factors of C have different signs. So when I'm looking at my final factored form, I'm going to have a plus or minus, and as in the previous examples, use a table to organize. So I do want you to keep in mind that since B ended up being negative here, the larger number, the larger factor, is going to be right there. Alright, that negative sign won out, so we want the larger number to be negative. So, looking at all the different factors of 4, I have more than I have before. There's 1 and 4, and then there's 2 and 2. And then the factors of -7, I've either got a 1 and a -7, or a -1 and a 7. So I have to look at all the different combinations. Alright, so, writing it all out in the different ways here, I would see that the first 4 that I've tried out with the factors of 1 and 4 aren't going to work out for me. Alright, keep in mind how I'm ruling them out is multiplying that outer and inner term in my foiling process to see if I got the B. So -3, it didn't work. 27 didn't work. 3 didn't work. -27 didn't work. And then I get to my 2's and my 2's. I see if I had tried this one out in the beginning, I'm like, okay, I'm almost there. I have a 12. Now I need a -12. So this is the factorization. That is our solution. So do not avoid any errors. Do not forget to write that -1 that you factored out in your final factorization. So yes, this 2x plus 1 times 2x minus 7 is a part of your solution, but you also have that negative 1 that you factored out at the beginning. So your total solution, your final solution, is going to have that negative sign in there. Alright, and you can always check by using a graphing calculator. So if in one line, y sub 1, you enter in your original quadratic here, and then into y sub 2, if you enter this in, you would know that without that negative sign out here in front, they're not going to be the same graph. Alright, so that would signal to you that you're missing something. So make sure to include that negative sign, that negative 1 that we factored out. So here's some guided practice. Please pause the video and then see if you get the same solutions. Alright, so finding a common factor. This is something we're going to talk about in our next video. So if you guys have any questions about just factoring in general, always feel free to ask. So finding a common factor. In lesson 9.4, you learned to factor out the greatest common monomial. We're going to want to do the same thing here. So, from terms of a polynomial, go ahead and factor out the greatest common monomial. Sometimes you might need to do this before finding two binomial factors of a trinomial. Okay. All of this to say, if you notice something that all of the terms have in common, go ahead and factor that out first. That's going to allow you to reduce those exponents, and it's going to allow you to reduce the numbers, just making it easier to go through the entire factoring process. So, example 4. An athlete throws a discus from an initial height of 6 feet with an initial vertical velocity of 46 feet per second. Write an equation that gives the height in feet of the discus as a function of time. So that means on one side you're going to be looking at an h, and on the other side you're going to have all of these t's. Alright, after how many seconds does the discus hit the ground? Keep in mind that the ground is a height of 0. Solution. The vertical motion model to write an use the vertical motion model to write an equation for the height h in feet of the discus. In this case, your velocity is going to be 46, and your s is going to be 6. Alright, so they did give you that 46, and they give you that 6 as well. Alright, here is your vertical motion model. This equation doesn't disappear just because we moved on in your book. Alright, replacing, substituting in those values, there's your equation. Alright, so that's your equation for part A. So to find the number of seconds that have passed before your discus lands, substitute in the value for, find the value of t when the height is 0. So you're substituting in the value 0 for h, your height. Okay, so then what we want to do from there is to actually solve for t. Solve for that time, we need to factor. So the first thing that you might notice is they are all even. Since they are all even, I am factoring out that negative 2. Alright, that's factoring out a common value or a common constant here. And then I go through the entire factoring process, and I can set up that chart. I can use trial and error, finding all the factors of 8, finding all the factors of 3, which our prime numbers here are just lovely. There's only a couple factors, and then using the fact that both of the signs are negative. So it's going to be 1 and 1. 1 positive and 1 negative. Alright, so yes, they only wrote this out in one step, however, there's more work to be shown behind it. Okay, so then to actually solve, we do what we've done before. Anywhere there is a variable, we use that zero product property. So I set each of those binomials equal to 0, and then I solve, and I get t equals -1/8 and t equals 3. So the solutions are -1/8 and 3. The negative solution doesn't make sense because it doesn't even say why. Alright, here you need to think about what you actually solved for. So let me go back here. T. You solved for t. What does t stand for? T stands for your time. Can you have a negative time? No, you can't have a negative time. So that's why the -1/8 doesn't make sense. Alright, so disregard that. So the discus hits the ground after 3 seconds. That is your final answer there. So what if instead, in example 4, suppose another athlete throws the discus with an initial vertical velocity of 38 feet per second and releases it from a height of 5 feet. Alright, so not only is the initial velocity going to have an effect here, so that initial speed, but the height of the thrower as well. So after how many seconds does the discus hit the ground? So go ahead, pause the video, use that vertical motion formula, and see if your solution matches. 2.5 seconds. So if I were to compare that after 3 seconds, who do you think threw further? Alright, probably the 3-second thrower instead of the 2-second thrower. Alright, so shot put. This is another guided practice for example 4. Feel free to pause the video, use that vertical motion formula as well. So the shot put hits the ground after 2 seconds. Alright, and our final example here, example 5. A rectangle's length is 13 meters more. Alright, that means I'm probably going to need to be adding, and I'm going to need a variable here. 13 meters more than 3 times its width. Alright, the area is 10 square meters. So, I have my width, and then I need to interpret this and write my length as 3w plus 13. And that is going to be equal to the area, which is 10 square meters. So I set that up. I go ahead and use my distributive property here. And I get 3w squared. And that should just be a 13w plus 13w minus 10. Moving forward, still scratching out that exponent. I then factor it. So I need to look at the factors of 3, the factors of 10, and the fact that my second sign here is negative, means I'm going to have a positive times a negative, and the higher product here is going to end up being positive. So when I do the foiling process, I get plus 15w minus 2w, and that's what gives me that 13w, alright, for my b term. And so, yet again, there is more work to be shown than just moving from line to line. Okay, so then using my zero product property, I'm going to have w plus 5 equals 0 and 3w plus or minus 2 equals 0. I'm going to solve those, and then I want to see which one makes sense. Alright, reject the negative width, of course, because a negative length never makes sense. Alright, if you can't measure it, you can't see it. So your correct answer here is A. So here's our final guided practice. Go ahead, pause the video, see if you get the solution. Alright, if you guys have any questions, always feel free to send me an email and ask.